Hello, it's Charlie again. You may recall in a previous video we used these models and animations to illustrate Cavalier's principle and this morphing pyramid over here to explain where the origin of 1/3 comes from in the volume formulas for pyramids and cones. Well, in this video we will be going into detail on how to make these models and animations. So a good place to start, I would guess, is this, morphing pyramid over here. So let's get started by making a new Blender file. And let's delete everything. We do not need anything in here. Okay, so believe it or not, we actually start with a plane. So Shift-A, Mesh, Plane. And we just got a simple plane. And now, let's make 20 copies of this plane going upwards. So to do that, we're just going to be using an array modifier. 20 of these, not 29. So 20. Constant offset. And let's not make it go horizontally. And let's make it go vertically by, let's say, 0.1. So now we have a cube formed out of planes. Pretty cool. So if I look at this, I don't usually think of pyramids. So yeah, let's apply a taper modifier so that we can make this cube made out of planes look more like a pyramid. So let's add a simple deform modifier, taper z-axis. Now notice that our edge length is going to be 2. And our height, let's say that we want our height to also be 2. And at a height of 2, we want our edge length to be 0. So therefore, our slope will be -1. So therefore, our factor for our taper is going to be -1. Boom. Okay, so now we got a great looking pyramid made out of 20 planes. But it's kind of looking a little bit thin, so let's fatten it up using a solidify modifier. So solidify. And let's say that we want our thickness of our solidifying modifier to be equal to like the missing gap. So that's just going to be 0.1. And let's set our offset to 0 so that the thickness is added evenly on both the top and bottom of our planes. Okay, so now that looks like a pretty good pyramid. But if you go to rendered view, yeah, it looks a little bit, sad. So we can maybe brighten it up by maybe changing its color to like, let's say like this bright yellow golden color. Didn't really help. Yeah, let's take an orange juice break. Okay, so one thing we could do is that we could add an environmental texture. And to do this, let's go to HDRI Haven. An HDRI is a high dynamic range image, and basically what they do is that they give you like a background, like a 360-degree background, and also give you lighting. So let's find one that we want. Let's say that we want it to be indoors, because why not? I did not want to find outdoors. I wanted to find indoors. There we go. So let's find the one that we like. So basically this is just going to be providing light and a background. So oh, this one. It looks pretty good. I've used this one before. It's an aft lounge. And you can just download it right here. And I downloaded the 8K version. So let's go back to Blender. Let's go into our color settings, set it to environmental texture, and open up our background, HDRI. So mine is located in my Blender folder. Open that up and give it a second, and there we go. So now our pyramid is in a cruise ship environment. It looks pretty happy in this. The lighting is great. And there's no one really around, probably because of COVID, but I guess that means our pyramid just gets like a nice little vacation. But wait, this is an educational math video, so there can't be any fun. So that means that we need to get rid of the background. But notice that the light still stays, the lighting still stays, and that's because we basically made the background transparent, but we keep all the lighting effects that the background gives us, the HDRI gives us. So that's pretty nice. So now our, pyramid looks really happy now. But it's time to slant this pyramid, so I don't think the pyramid will be any happy now. So what we could do is we could just set the origin of our taper to, let's say, be maybe over here, and if that's the case, then our apex will just be shifted over here. So to do that, let's add an empty. So to do that, Shift A, empty, let's say arrows, because arrows are cool. Let's make the radius 0.1 because we don't really need to see it. And let's say that we want it to be at this, I guess, point here. So that's just going to be -1 in the x and -1 in the y. So now our empty is at this corner of our pyramid. So now we could just set the origin of our taper, I guess, modifier as our empty. And boom, now we have a slanted pyramid. Okay, that's looking pretty cool. So now what we want to do is that let's apply all of our visual geometry to a mesh. So object, apply visual geometry to mesh, and make sure to keep the original, like so. Okay. Well, now we have our original copy, not original copy, but like original pyramid. And then now we also have our, I guess, pyramid with all the modifiers already attached, already applied. So now we could just move our empty back to the origin of our world, so 0, 0, and now we have a happy non-slanted pyramid now. So yeah, that's looking pretty good. Now we have one pyramid and a slanted pyramid. So now we could just apply our visual geometry to our mesh of this non-slanted pyramid that you would expect to see in Egypt. I'm pretty sure that all the pharaohs would be very proud of this. Okay, so now let's make shape keys. So let's first select our original pyramid and select our slanted pyramid too. Let's go to our mesh tab, mesh window, mesh tab, same thing. Let's go to our shape key specials and join these two, I guess, pyramids as shapes. And notice that now when we, I guess, move our value to the right, you notice that our slanted pyramid is becoming more like our non-slanted pyramid, and we can make it dance left to right, and yeah, it's pretty cool. But now we actually don't need this anymore, so we can just hide this now, and we can also hide the empty if we won't be needing that anymore. So now that we've made our slanted pyramid, let's make our pyramid actually look pretty good. So to do that, let's use our shader editor, but once again, let's take a orange juice break. Okay, so now let's make a new window like so. Zoom this out a bit. Rendered view, and let's make this into our shader editor. So notice that currently we just have our diffuse shader going straight to our material output. But let's say that we want a bit of transparency. So to do this, we could just do Shift-A, search, and let's say mix shader. And there we go. So now, I guess, let's throw in some transparency. So let's do Shift-A, transparent, BSDF, and hook that up with our mix shader. And wow, nothing changed. So to actually make it change, or at least allow our material to have some transparency, we need to switch our blend mode from opaque to our alpha blend mode. And this basically means, for alpha, means transparency, so therefore we could actually see transparency now. Wow, cool. So let's name this material, let's say pyramid material. Let's move the factor down to 0.1 because it is just, I don't know, like a simple pyramid material. No need for too much transparency. But now let's make a copy of this, call this pyramid transparent. And you guessed it, we're going to be making this very transparent, like so. Wow, that actually looks pretty good. Okay, so now that we got our materials all sorted out, I think it's time to separate our pyramid out into separate slices. So let's go to edit mode, P for separate by loose parts, and now we have each of our rectangular prisms all separated out. Go back to object mode and create a collection. Let's call this pyramid slices. Wow, creative name. I am so original. Okay, so after that, now, I guess that now we want to maybe change the material of each of our slices depending on what frame we are at on our timeline. So to do this, we're going to be using an add-on called Animation Nodes, and it's apparently one of the best add-ons for Blender. I've not really used many add-ons, but this is certainly a very neat add-on. So just download the long-term support version, that's the one that I did, and then just go to Edit, Preferences, and Install. Locate the file. For me, it was in Downloads, just installed add-on. And then after that, let's search up our animation nodes, and let's take that checkbox to on. So now we have animation nodes. Take another orange juice break because I'm thirsty. Okay, now we can switch our shader editor to our animation nodes. Wow, crazy. Very lots of things going on in this window right here. But let's just add a new node tree. Okay. So now we have our collection with all of our fancy, I guess, objects. So we want to, I guess, go through all of these objects and compare them with our, I guess, frame in our timeline. So to do this, we actually need to get the objects first. So to do this, let's throw in an expression. Not expression. What am I thinking? Let's actually throw in a collection info, so we could get information about our collection, which the objects are in, and we could just select our collection info, and we could just select our, I guess, collection that we want to go through. Okay, so now, let's go to subprograms and have a loop. So this means that we're just going to be going through all of our objects inside this collection, but we need to actually tell it to do that. So let's add a new iterator, object list, like so, and now when we run our loop, it's basically just going to go through all of these objects. Pretty cool. So now let's initiate our loop, and after we initiate it or invoke it, we actually need to change the name to something very original, something that just inspires creativity, and that'll just be I don't know, pyramid material loop. Wow, crazy name. Okay, so now I guess that's time to compare it with our frame. So to do this, we're just gonna be using an expression. And yeah, it's just an expression, nothing too special. So let's hook up our objects to our new input, and let's just do obj, say, as our name for our object, because that's like the first three letters, and first three letters are cool. So now let's get the location in the z-axis. So let's do this by doing obj.location.z. Okay, then after that, let's I guess look at what we have so far. So Shift A, subprograms, actually not subprograms, viewer, loop viewer. So now we can take a look at what we got. Let's make a new text file, and let's switch from our outliner to our text editor. Let's open up our text, our loop viewer, and let's shift around. Wow, they're all zeros. Let's quickly take an orange juice break. Oh, I know what we forgot to do. We actually forgot to set the origin of each of these rectangular prisms to their geometry. So let's do that quickly. So let's switch back to our outliner and select all of our pyramid slices. Let's select all of our pyramid slices like so, and then after that, object set origin to geometry. Now let's take a look. I hope that this fixed it. So let's go back to our text editor, shift our timeline. Whew, okay, close call. Let's try not to replicate that again. So now let's multiply our, I guess, locations in the z, in our z locations by 10. So now that we have more round numbers, then we can get rid of that decimal point. Oh, we did not get rid of the decimal point. Well, we can fix that by just rounding our numbers out, like so. Okay, now let's shift our timeline a bit, and now we got rid of all of the decimal points. Pretty cool. So now we want to compare our frame. So let's say that we're at like frame, I don't know, like 6. So notice at 6 it's 5. So therefore all of these will be true. So now, yeah, let's just compare them. So to do this, let's add in a frame. Just gonna grab our current frame that we're at, and let's hook it up as a new input. Maybe call this F because F is frame. And yeah, so now if the, I guess, the Z location of that particular rectangular prism is less than our frame, then therefore it will be true or false. So if our frame is greater than the location of the z-axis, it will be true. So let's take a look. Oh wow, it actually works. Dang. So you notice that at frame 0, everything is false. At frame 1, the first rectangular prism is true, and it just goes continuously upwards. Okay, so now we can get rid of our loop viewer now that we confirmed that it is working. Okay, so now what we want to do is let's get our materials, because if it is true, we want it to be a certain material. If it is false, we want it to be a certain material. So to do that, let's just get a material list, create a material list, and put it right under our expression. Woo! Okay, another orange juice break. Oh dang, I'm actually running out of orange juice. That's not good. So now, yeah, let's get our materials. So, when our expression says false, we want it to be pyramid transparent. And when it says true, we want it to be our regular pyramid color. So therefore, if our frame is greater than our location of our location of our, rectangular prism at its Z location, then we want it to be just this more like less transparent pyramid color. So yeah, let's throw in, it's like get list elements. So now we get our list elements. Let's switch this back to outliner. Okay, so now we can just throw in our list to our list, and notice that our index 0 means false, 1 means true. So therefore, if our frame is greater than the location of our Z object in the Z axis, then therefore it will be 1. So let's just hook that up. Now let's move it around. Notice that nothing happens, and that's because we don't have an object output. So let's get that. So I think it's material object output. There you go. Object material output. Close enough. So now let's hook our element with our material, since this will determine our material. And now we got our object. Let's hook that up with our object. Wow, nothing happened. But now when we shift over, oh wow, so now as we go up and up our timeline, you notice that our materials for our rectangular prisms change along with our frame that we are currently at. Okay, that's pretty cool. But what about cones? Well, we can start by making a cone by, starting with a circle, because circles equals codes. It's proven. That was a joke. So let's make our vertices of this, circle to be 120, so that they are quite smooth, and let's move it along the x-axis by 3. So there we go, and now we can actually fill in our circle. So let's go into edit mode of the circle and fill it in with a face. This allows us to solidify our cylinder later. Not cylinder, cone later. Okay, so now that we got this, we can now array it by 20 upwards. So let's have 20 of them, and we're just going to be having a constant offset, not relative offset. And we don't want it to be going to the right or left or the x-axis, y-axis. We actually want it to go into the z-axis. And let's say 0.1, so our height will be 2 at its highest extent. Okay, pretty cool. Now, it's like it's like a cylinder now. We want it to become a cone. So we can fix that by just adding another modifier, simple deform, taper this down on the z-axis, and notice that our diameter is 2. We want our height to be 2, and at our height of 2, we want our diameter to be 0. So therefore, our slope will be -1, and that's going to be our factor. Boom. Okay, so now our cone is now taking shape. So once again, we want to thicken this up using a solidifying modifier, like so. We want our thickness to be equal to our gap right here in between each of our slices. So that's just going to be 0.1. There we go. And our offset, once again, is going to be 0, just so that the thickness is added evenly on both the top and bottom of our planes. Boom. Okay, so now we got our cone. It's looking pretty good, but now it's kind of bland. So let's add a material to it. So first off, let's actually move our cone outside of our pyramid slices collection. Just move it right below it, because why not? Okay, so now let's maybe just recolor the pyramid colors. So make a copy of the pyramid color, call it cone. Say that this color will be maybe this bright cyan color, very happy color. And now let's make a cone transparent version, transparent. And let's increase factors to 0.95. And the reason for that is just because we want our mix shader to maybe be more just to be taking in more of the transparency. Okay, so now we got a beautiful cone and our pyramid. So yeah, let's apply all of our visual geometry to our mesh. And we do not need to keep original this time. Let's tab. Let's separate out all of our cylinders. And yeah, so let's just separate them all out. Okay, looking good. Let's add them. I guess like add a collection for all of them. Call this maybe cone slices. There we go. And now let's not make the same mistake that we did earlier. And now let's actually set the origin of each of our cylinders to be at their geometry. Boom. Okay. So yeah. I guess that it's time to get back to animation nodes. So it's basically like the same thing. Let's copy everything, and we can just make some slight adjustments. So let's just paste it in, zoom in a bit. So instead of pyramid slices, we want it to be cone slices. Let's name this to something even more original, the pyramid material loop. Let's say cone material loop. Wow. Wow, so original. And let's switch it to cone material loop, our subprogram. And then let's move it around, and notice that our materials are still at our pyramid transparent and pyramid. So let's switch that out for cone transparent and cone materials. And yeah, let's give it a try and see if it works. Dang, it actually works, and it actually looks quite good. So let's unhide our, I guess, like, moving pyramid, and let's move it in the X direction. Let's quickly just move it in the X direction by, let's say, -3. So now it is on like the side, and let's change the material so that looks actually kind of good. Let's say this this pyramid transparent material, and there we go. So now we got our working shape key, and we got our animations and models that we used in that previous video. So yeah, thank you for watching. And yeah, I'm currently working on my next video, which is going to be about where the factor of 4/3 comes from when finding the volumes of spheres. Yeah, I almost said circles, but I caught myself. And I'm just gonna finish this up because there's like a sphere that I kind of want to show you. So yeah. Sphere. So yeah, thanks for watching. Consider subscribing so that you would be notified when that video is uploaded. Okay, I'll see you guys next video. Bye!